In the vast expanse of aviation history, certain machines stand as colossal monuments to human ingenuity and engineering prowess. Among these towering giants, the Mil V-12 emerges as a Soviet marvel, a titan of rotorcraft innovation that defied the limits of imagination and possibility. Imagine a behemoth of metal and machinery, a flying colossus that dwarfed its contemporaries, challenging the skies with its sheer audacity and ambition. This is the story of the Mil V-12, a machine so monumental that it redefined our understanding of what a helicopter could be. Picture the scene: the Cold War era, a time of ideological strife and technological one-upmanship. In the midst of this geopolitical turbulence, Soviet engineers dared to dream of a flying behemoth that could transport troops and equipment with unparalleled efficiency and power. Enter the V-12, a machine that would leave an indelible mark on the annals of aviation history. But what exactly was the Mil V-12? Was it truly a helicopter, or something else entirely? How did it achieve the seemingly impossible feat of flight, defying the laws of physics with its immense size and weight? Join us on a journey through time and space as we unravel the mysteries of this Soviet rotorcraft titan, exploring its origins, capabilities, and legacy. Prepare to be awed and inspired as we delve into the heart of this engineering marvel, uncovering the secrets of its design, construction, and performance. From its maiden flight to its ultimate demise, the story of the Mil V-12 is a testament to human ingenuity, perseverance, and the relentless pursuit of greatness in the face of insurmountable odds. So buckle up, aviators, as we embark on a thrilling adventure through the skies of history, guided by the awe-inspiring legacy of the Mil V-12. In the realm of aviation, few sights evoke as much awe and admiration as the majestic silhouette of a heavy helicopter looming on the horizon. These colossal machines, with their sheer size, weight, and capabilities, command attention and respect wherever they go. From airlifting troops and equipment to conducting daring search and rescue missions in the most remote corners of the globe, heavy helicopters have earned their place as indispensable tools of modern aviation. Amidst the pantheon of heavy helicopters, one machine stands apart as a true icon of Soviet engineering prowess: the V-12. A titan of rotorcraft innovation, the V-12 emerged during the height of the Cold War, a period marked by intense geopolitical rivalry and technological competition between the East and the West. Designed to push the boundaries of what was thought possible in aviation, the V-12 represented a bold leap forward in helicopter design and performance. But what exactly was the V-12? How did it achieve the seemingly impossible feat of flight, defying the laws of physics with its immense size and weight? Was it truly a helicopter, or something else entirely? These are the questions that have intrigued aviation enthusiasts and historians for decades, fueling speculation and fascination about the enigmatic nature of this Soviet rotorcraft titan. The Cold War era was a time of unprecedented technological innovation and rivalry between the superpowers of the United States and the Soviet Union. As the space race captured headlines and imaginations, a parallel arms race unfolded in the realm of aviation, driving both nations to push the boundaries of aeronautical engineering to new heights. Against this backdrop of geopolitical tension and competition, helicopters emerged as a critical tool for military and civilian applications, offering unparalleled versatility and maneuverability in a variety of environments. Central to the advancement of helicopter technology during the Cold War was the development of turboshaft engines. Unlike traditional piston engines, which were heavy and inefficient for helicopter use, turboshaft engines offered a revolutionary solution that greatly enhanced the performance and capabilities of rotorcraft. By harnessing the power of gas turbines, turboshaft engines provided helicopters with the thrust and power necessary to lift heavy payloads, fly at higher altitudes, and achieve greater speeds than ever before. This technological breakthrough not only expanded the operational envelope of helicopters but also paved the way for the development of larger and more capable rotorcraft like the V-12. The V-12 was not conceived in isolation but rather emerged as the culmination of decades of innovation and experimentation in helicopter design. One of the key precursors to the V-12 was the Mi-6, a massive transport helicopter that first took to the skies in 1957. With its impressive size, payload capacity, and range, the Mi-6 shocked the world and set a new standard for heavy-lift helicopters. Its success demonstrated the feasibility of transporting large payloads by air and inspired Soviet engineers to dream even bigger with the development of the V-12. In many ways, the Mi-6 served as a stepping stone towards the realization of the V-12's ambitious vision, laying the groundwork for the next generation of Soviet rotorcraft innovation. Amidst the geopolitical tensions of the Cold War, military strategists on both sides recognized the critical importance of rapid troop and equipment transport for maintaining strategic advantage. In an era characterized by the threat of global conflict and the need for rapid response capabilities, helicopters emerged as indispensable assets for military forces around the world. Their ability to bypass traditional logistical constraints and deliver troops and supplies directly to the battlefield made them invaluable tools for both offensive and defensive operations. As such, there was a pressing demand for larger, more capable helicopters that could carry heavier payloads over longer distances in shorter time frames, thus enhancing the military's ability to deploy forces rapidly and effectively in any theater of operations. In response to the military's demand for enhanced transport capabilities, engineers began to explore the concept of a hybrid aircraft helicopter transportation system that could combine the best attributes of both fixed-wing aircraft and rotary-wing helicopters. This envisioned system would consist of an aircraft capable of delivering cargo to conventional airfields, followed by a helicopter capable of transporting that cargo to more remote or inaccessible locations with precision and efficiency. By pairing the speed and range of airplanes with the vertical takeoff and landing capabilities of helicopters, this hybrid transportation system promised to revolutionize military logistics and deployment strategies, offering unprecedented flexibility and versatility in the movement of troops and supplies. The conceptualization of the MIL V-12 was born out of this ambitious vision for a hybrid aircraft helicopter transportation system. Tasked with the monumental challenge of designing and building a rotorcraft capable of carrying payloads of up to 40 tons over vast distances, Soviet engineers faced a host of complex design challenges and technical hurdles. From structural integrity and aerodynamic stability to power plant efficiency and payload capacity, every aspect of the V-12's design had to be carefully considered and meticulously engineered to ensure its success. Yet, despite the daunting nature of the task, the engineers tasked with creating the V-12 were driven by a relentless ambition to push the boundaries of what was thought possible in helicopter design, determined to create a machine that would not only meet but exceed the military's demanding requirements for rapid troop and equipment transport. In the early stages of conceptualizing the V-12, engineers at the MIL Design Bureau explored various layout options to determine the most suitable configuration for achieving the desired performance and capabilities. Among the options considered were the tandem layout, where the rotors are positioned one behind the other, and the transverse layout, where the rotors are positioned side by side. Each layout offered its own set of advantages and challenges, with the tandem layout providing simplicity and familiarity but potentially limiting the size and weight of the helicopter, while the transverse layout offered greater payload capacity and stability but presented unique engineering challenges related to rotor placement and aerodynamics. After careful consideration, the engineers at the MIL Design Bureau ultimately opted for the transverse layout for the V-12. This decision was driven by the desire to maximize the helicopter's payload capacity and stability while minimizing the risk of rotor interference and imbalance. By positioning the rotors side by side, the transverse layout allowed for a larger and more stable platform, enabling the V-12 to carry heavier payloads over longer distances with greater efficiency and control. Additionally, the transverse layout offered the potential for improved aerodynamic performance and reduced drag, further enhancing the helicopter's overall capabilities. Despite the advantages of the transverse layout, its implementation presented a number of significant challenges for the engineers tasked with designing the V-12. One of the primary challenges was rotor placement and aerodynamics, particularly in mitigating the risk of rotor interference and imbalance. With the rotors positioned side by side, there was a heightened risk of the rotors overlapping or colliding during flight, which could result in catastrophic failure. To address this challenge, the engineers developed innovative solutions such as optimizing the spacing between the rotors, incorporating advanced rotor control systems, and implementing safety features to prevent rotor collision. Additionally, extensive aerodynamic testing and modeling were conducted to optimize the helicopter's airflow characteristics and minimize drag, ensuring optimal performance and stability in all flight conditions. Through meticulous design and engineering, the MIL Design Bureau was able to overcome these challenges and create a rotorcraft that pushed the boundaries of what was thought possible in helicopter design, paving the way for future advancements in heavy-lift aviation. As the culmination of years of meticulous design and engineering, the V-12 prototype emerged from the hangars of the Mil Design Bureau as a true testament to Soviet innovation and ambition. With its imposing silhouette and groundbreaking design, the V-12 captured the imagination of aviation enthusiasts around the world, promising to redefine the capabilities of heavy-lift helicopters in ways previously thought impossible. The V-12 was a marvel of engineering ingenuity, boasting dimensions that dwarfed those of its contemporaries. With a length of 37 meters, a wingspan of 34.4 meters, and a height of 12.5 meters, the V-12 was akin to a flying fortress, capable of carrying payloads of up to 40 tons with ease. Its transverse layout, with two massive rotors positioned side by side on wing-like structures, gave the helicopter a distinctive appearance that set it apart from traditional rotorcraft designs. Additionally, the V-12 featured a reinforced wing structure, high lift devices, and a complex tail assembly, all of which contributed to its exceptional stability, aerodynamic performance, and payload capacity. In comparison to contemporary aircraft and helicopters of its time, the V-12 was in a league of its own. While traditional helicopters like the Sikorsky CH-53E and the Mi-26 were impressive in their own right, the V-12 eclipsed them in terms of size, payload capacity, and capabilities. For example, the Mi-26, often regarded as the largest helicopter in the world, paled in comparison to the sheer magnitude of the V-12, which boasted twice the payload capacity and unmatched lifting capabilities. Similarly, even the largest cargo aircraft of the era, such as the Antonov An-22, could not match the V-12's ability to deliver heavy payloads to remote or inaccessible locations with the precision and agility of a helicopter. As such, the V-12 represented a quantum leap forward in heavy-lift aviation, pushing the boundaries of what was thought possible and setting a new standard for rotorcraft innovation. The Mil V-12's operational capabilities were as versatile as they were impressive, making it ideally suited for a wide range of civilian and military applications. With its staggering payload capacity of up to 40 tons, the V-12 could transport a diverse array of cargo, from heavy machinery and equipment to troops and supplies, with unparalleled efficiency and precision. This versatility made the V-12 indispensable for a variety of missions, including logistical support, disaster relief, and military operations, where rapid deployment of personnel and equipment was critical to success. Loading and unloading cargo onto the V-12 was a streamlined and efficient process, thanks to its innovative loading and unloading mechanisms. The helicopter featured a tail door similar to that of an aircraft, which, when opened, revealed a ramp for easy access to the cargo compartment. Additionally, hydraulic supports were deployed to ensure stability and safety during loading and unloading operations, preventing the helicopter from tipping over or becoming unbalanced. This design allowed for quick and hassle-free loading and unloading of cargo, minimizing downtime and maximizing operational efficiency. Inside the V-12, careful attention was paid to the interior layout and cockpit design to ensure maximum comfort and functionality for the crew. The spacious cabin was equipped with large windows to provide excellent visibility and natural light, creating a comfortable working environment for the crew during long flights. The cockpit was designed with ergonomics and ease of use in mind, with intuitive controls and instrumentation that allowed the pilots to operate the helicopter with precision and confidence. Additionally, amenities such as climate control and soundproofing were incorporated to enhance crew comfort and reduce fatigue during extended missions. Overall, the interior layout and cockpit design of the V-12 reflected a commitment to excellence and a dedication to meeting the needs of the crew in any operational scenario. The Mil V-12 faced initial flight challenges, as is common with pioneering aircraft. Its maiden flight encountered difficulties, with instability and control issues leading to a hard landing. However, these setbacks served as valuable learning experiences for the engineering team. Subsequent modifications were swiftly implemented to address the issues identified during testing. Notably, adjustments were made to the control system to enhance stability and responsiveness, ensuring smoother and more controlled flight operations. These modifications proved successful, paving the way for further testing and development of the V-12. Despite its early challenges, the V-12 went on to achieve remarkable milestones in lifting capacity, altitude, and range. During rigorous testing, it demonstrated its exceptional lifting capabilities by successfully hoisting heavy payloads to impressive heights. One notable achievement was the lifting of over 44,000 kilograms to an altitude of over 2,200 meters, setting a new benchmark for heavy lift helicopters. Additionally, the V-12 showcased its versatility and endurance with an impressive range of 500 kilometers, making it capable of reaching remote locations with ease. These achievements solidified the V-12's reputation as a groundbreaking aircraft with unparalleled performance capabilities. The V-12's prowess was showcased on the international stage with its participation in prestigious events such as the Paris Air Show. This renowned event provided an opportunity for the V-12 to dazzle spectators and industry professionals alike with its awe-inspiring size and capabilities. As it soared through the skies above Paris, the V-12 captured the attention and admiration of attendees, earning accolades and recognition for its groundbreaking design and performance. Its presence at the Paris Air Show underscored its status as a pioneering aircraft and a symbol of Soviet engineering excellence. In conclusion, the story of the MiL V-12 serves as a poignant reminder of the boundless ambition and innovative spirit that drive progress in the field of aviation. Despite its eventual demise, the V-12 remains a symbol of Soviet engineering prowess and a testament to the extraordinary capabilities of heavy-lift helicopters. Its legacy endures as a testament to human ingenuity and the relentless pursuit of advancement in aviation technology. We hope you've enjoyed this exploration of the MiL V-12 on our channel. If you're hungry for more fascinating aviation stories and insights, be sure to explore our other videos. From historic aircraft to cutting-edge technology, there's always something new to discover in the world of aviation. Don't forget to engage with us by liking, commenting, and subscribing to our channel. Your support helps us continue to bring you high-quality content and allows us to delve deeper into the fascinating world of aviation. Thank you for joining us on this journey, and we look forward to welcoming you back for more exciting adventures in the skies. With that said, thanks for joining us for this look at the MiL V-12. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more great aviation content. If you have any questions or comments, please leave them in the comments section below. Thanks for watching, and we'll see you in the next video.